Marcus and Michelle and others for the opportunity to speak today. I'm really happy to be part of this webinar. So I've been asked to give a little bit of overview of some of the things going on around science gateways in the U.S. right now. And so what I'm going to start with, if my slides advance, oh, there we go. It's just sort of some background into how we got to where we are now. So many of you are probably familiar with this. This is the National Science Foundation's cyber infrastructure vision for the 21st century, and there have been a lot of funding programs that have kind of come out of this. And it started with a series of task forces, and I'll go into that a little bit next. But the main message here in this slide is about the connectivity needed for science and kind of the different components that you see in this flower petal diagram here. And what we're kind of emphasizing in this talk is the fundamental role that software plays in connecting all of these different things. So we're seeing more and more of this in the XSEDE program, in some of the programs that are driving hardware acquisitions, just really novel uses of cyber infrastructure, and very much this emphasis on connecting facilities and people and laboratories and data stores and all sorts of different things in kind of a much more advanced ways than have been needed previously, I would say. So there was one particular task force focused on software, and they came up with a number of recommendations. And this first recommendation is what my talk's going to sort of center on, is these different levels of funded activities. So kind of the need for small research team software, and then kind of larger, more integrative software projects, leading to kind of more persistent software institutes, and kind of how those things relate to science gateways. So this is kind of another vision of the same thing. So software elements being the small group pieces, the frameworks being kind of the coming together of some of those pieces, and then the institutes being kind of more long-term centers of excellence. And this has kind of left us with some nice confusing acronyms, from the SI2 that you see at the top of the slide to SSE, SSI, S2I2. I myself am always having to remind myself whether it's S2I2 or SI squared or so even many years in, this is yeah, still a poor choice of acronyms. So the institutes are seen as these long-term hubs of excellence, and I have not seen NSF do something of this, I don't know if I would say magnitude, but maybe persistence around software in quite some time. We have engineering research centers and science and technology centers, but it's sort of rare, in my experience, for the NSF to go out on a limb and kind of propose something of any decent size that's really persistent. They really like to kind of fund an awful lot of projects rather than smaller, larger projects. So this is kind of a significant vote of confidence in these sorts of institutions, and it's very much an experiment for them. And some of that kind of plays out in the way the solicitations are worded and the way they've kind of carefully stepped into those solicitations. Yeah, but it is something a bit novel in that regard. So these are supposed to be multidisciplinary institutes and really do an awful lot of things. So kind of support the software developers at all different levels, and in addition have workforce development components and diversity components. These are always part of procurements, and especially things of this size. They're not supposed to be very large pots of money to develop individual pieces of software. So how does this relate to some of the things that I've been doing in the Science Gateway area? So I got started in Science Gateways about, 11 years ago now. It doesn't seem like that long. But we started this program back in the TERN grid in 2004, and the recognition there was, you know, typically supercomputer access has been, had up to that time been quite traditional, where we have names and addresses and we know exactly who every user is. People log on at a Unix command line and they run jobs through queues, and the people that have access are a principal investigator who writes a proposal, as well as that investigator's students or collaborators or things like that. So very much kind of contained groups of people and known quantities of people. And so early on in the TERN grid, you know, we were starting to see a lot more advanced web development for the sciences. So we had a program called, gosh, I can't remember the name right now, but it was a program that created sort of shotgun marriages between applications and technologists, if you will. And a lot of these shotgun marriages were pretty painful in the early going, but many of them grew into some significant collaborations that we see, you know, today, 10 years later. But early on, it was very much a forced sort of thing. We were just beginning to see, you know, kind of a real interplay of scientific applications and technology in a more complex way than just running software simulations over and over, that sort of thing. So, So back at the beginning of TERN grid, the idea was, you know, we're seeing these web interfaces pop up all over the place, and wouldn't it be powerful if, you know, instead of running on local servers when people do simulations or use these interfaces, we could back end supercomputers to these things. And so now you have the same web interface that you're comfortable with, but now all of a sudden you can do much larger simulations, you can get things done many times faster, many more people can use the interface at once, that sort of thing. And so there was a lot of work in the early years just around policies, you know, how could we do such a thing? So now we've got sort of semi-anonymous access to supercomputers. Is that okay? What sort of policies do you need in place for that to work successfully? So we did a lot of work around that, and also with our whole allocation process, because now once you've got a web interface, you can no longer say, okay, PI X and his or her 5 graduate students are going to run code Y, and they're going to do it Z number of times, and you know sort of exactly what's being done with the computer time. So we had to make a strong case for the allocations review boards that, you know, now these could be scientists from all over doing all manner of things. It was still sort of fairly determined what they were doing because of the plumbing in the web interfaces. You could only run particular codes, for example. So there were still, you know, it wasn't like a complete free-for-all. But still, we spent a lot of time kind of making sure that requests for high-end computer time would be successful for this type of usage, which was very new. And so we were able to do that, and we were really happy about that. So now 10 years going in, we actually saw, I think it was about a year ago at this time, we now on the NSF systems have more users coming in through these Science Gateway interfaces than we do coming in through the command line. So that's I see hundreds and hundreds of publications and some very productive use of the interfaces. So that part's kind of come a long way in those 10 years. And what running that program allowed me to do was see many different types of gateways, because the TERN grid program didn't fund the front-end development of any of these things. All we did was help with the back-end plumbing, if you will. So we would see, and that I think was very well, you know, one, it was we had to do it for financial reasons and scope reasons, but two, it made the gateways cut. I mean, the gateways really came from their own community, so it wasn't an external supercomputing group saying, okay, this is going to be what the bioinformatics gateway looks like. This is going to be what the computational chemistry gateway looks like. Those were funded through domain science programs at the NSF and kind of grew organically that way. So that, I think, was a really good decision, but it also allowed us to see many different projects, and we see similar challenges across domains. We would see similar struggles funding, because these things, as you all kind of know, I'm sure, they sort of straddle this land of cyber infrastructure versus research. So even though they enable research, in and of themselves, they're not supposed to be research projects. And so that can sometimes make a funding path difficult to find in the U.S. So we saw a lot of, you know, kind of recreating things in a vacuum and commonalities of needs between gateways from many different domain areas, and just sort of saw, you know, a lot of these things over the years. And we see, you know, really popular gateways come and go, even if they have large user bases. And then you see, you know, kind of disillusionment among the science community, and, you know, reluctance to step in and use these things in the future, and just sort of a bit of a vicious cycle. So this slide kind of describes a bit of that. So then we did a very small study where we kind of looked at what the characteristics of successful gateways might be, and what some of the challenges would be, and also what kinds of things we might do to break this cycle. And that's what I'm going to go on and talk about a little bit more here. So we're starting to see increasing prominence of the term science gateway in NSF awards, although they're also called other things, and there's no reason that they all need to be called science gateways. I mean, I think we understand what they are. It just makes it a little bit difficult when you're searching awards to find everything that's going on, because you don't have kind of a common keyword to search for. So there are several gateway projects being funded right now, and what's also interesting is we're starting to see solicitations that say in the solicitations, you can use an existing science gateway for this work, and in fact that would be a good idea. And so that to me was really powerful, because now, you know, an NSF program is saying, we're going to fund you to do this work, and rather than reinventing any sort of thing, you can use this existing gateway. You know, we've looked at this. This has the capabilities to satisfy this solicitation, and so use this existing structure and then do your own research on top of that. So this was a really nice thing to see recently. A lot of publications referencing gateways, but what you don't see here is that so the most popular gateway using XSEDE resources right now is called Cypress, and it's a phylogenetics gateway. So that gateway alone has 1,500 publications referencing Cypress. So that is probably, you know, unless the authors call it a science gateway, which they might or might not, those references aren't going to show up in something like this. Cypress works very hard, of course, to collect those publications, because that's what they need to show that they're, you know, relevant and useful and all of those things. But it's, you know, it can be a bit difficult to tell what's going on in terms of publications by just looking for the word science gateways. But really, there's, you know, it's kind of interesting. I have an alert set up on Google Scholar, and you know, it used to be that I was kind of familiar with a lot of the authors and a lot of the projects, and now that's less and less true, and that's really a good thing. I see them kind of coming in from all manner of different places, and that's exciting. So getting back to this software funding program in the NSF and these three levels, SSEs, SSIs, and the large-scale institutes, this solicitation came out this past spring. And so this has been, I don't know, I would say about a 3-year wait for the real implementation phase of these software institutes. And so at last this has come out this spring. And it's really exciting to me anyway that Science Gateways was named as one of 2 focus areas for these very large-scale institutes. So chemical and materials research was one, and Science Gateways was the other. And the solicitation goes on in some detail to describe what's wanted here. But myself and others who've been working in this area for some time, we're really thrilled to see the recognition that, yes, the NSF actually thought this was a good idea and a cost-effective way to help others build gateways, because that's really what we're all about with this. And so the results are not yet known yet. Proposals are in. I don't know. It will probably be about the spring before we've heard one way or the other if we've been selected to implement one of these things. But we certainly hope so. We've been working at this for a long time and just recently finished a large-scale survey of principal investigators at the National Science Foundation. Out of 29,000 folks that we sent this survey to, we had about a 5,000 person response rate, about 17%. We were pretty happy with that because these weren't sort of down-selected principal investigators who said they were interested in Science Gateways. This was all investigators. And so we kind of asked them about their involvement in developing such interfaces and their interest in shared services and some things like that. Yeah, we're working hard right now to kind of de-identify that data set so that others are allowed to look at it and search it. It's got some valuable information, I think, because one, it's so large, and also it's got the principal investigators by domain area. So you could look and see, you know, gee, engineers use web interfaces to access high-end computing resources, but not so much data collections, and people in the humanities, you know, don't use web interfaces to access instruments, but they do use them for data collections, things like that. There's sort of a lot of detail in there and a lot of different ways you can kind of slice and dice the results that we're just beginning to understand ourselves, and I think will be kind of powerful for others to take a look at as well. So this is the sort of things, and this second set of bullets is the kind of things that we think are going to be really compelling in such an institute. So we envision this as kind of you know, I think most people are familiar with the term business incubator, where you provide a lot of services that a small business will need to kind of get up and off the ground. So people would have difficulty hiring, say, large staffs with a variety of expertise that you need to get off the ground. Maybe you need an accountant for a little while. Maybe you need a marketing person for a little while. You know, you need sort of bits and pieces of people, and that's kind of what we envision for this institute, to kind of help these projects get off the ground, but also to help them design kind of for the long term, because a lot of times these projects are funded as kind of 3-year short-term research projects, and then, oh, lo and behold, you know, the web interface actually gets popular and you have a lot of users, and sort of now what do you do and how do you scope things out into the future? And if you don't figure that out quickly enough, the funding can be gone and the gateway has to close down, and that's sort of, you know, sort of not good for anyone. So thinking these things through from the beginning, we think will be a powerful thing that we might add. Let's see. So I think I go into these offerings one by one in just a tad more detail. So the incubator service is probably one of the more powerful, and it's basically putting forth these shared resources that many gateway developers can share. So you can get some advice on a business plan development. You can get some advice on licensing, even though there's going to be, you know, individual and university-specific issues around there. You can at least let people know what they ought to be thinking about, what others have done, what the options are, advice on cybersecurity, especially advice on the graphical user interfaces and usability design and things like that. A lot of scientific development teams won't have that kind of expertise and won't be able to hire in a full-time person, especially for a small project. We're also, one of the things we've done in the XSEDE program that's been really popular with the science community is something called extended collaborative support. And so we pair cyber infrastructure experts with research teams in a more in-depth way for up to a year. So the way we do it in XSEDE, which might or might not exactly translate to this, is we have people spend a quarter time with one research group for a year. And so you're able to dive in a lot deeper than just, kind of a simple help desk exchange, and really kind of take our research team to the next level in terms of optimization, code optimization, implementing visualization, helping with gateway design, workflow implementation. So there's a lot of different things that we do in XSEDE, and it's been received tremendously well by the science community. So we think that such a thing will transfer well here also. So in XSEDE, we try to take the same approach that we did in TeraGrid, where we'll help with back-end plumbing to supercomputers. But in actual fact, gateways do much more than just supercomputing. I work with ones that have done that because of my history with TeraGrid, but there's all manner of terribly effective gateways that don't use supercomputers at all. And so there's a lot that we were kind of missing in the XSEDE program because we couldn't work with this larger group and because we tried to stay away from front-end design and all of that. So now we're able to kind of jump in all these areas where we previously said, no, sorry, we don't do that. So this is another part of what we have in mind. The sharing, this is sort of the less siloed approach to gateway building. On my last slide, I'll mention kind of the workshop series, one of which is the Australian series in October that we're really excited about. But so we envision through these software institutes that have kind of this high-level visibility in the NSF of really kind of creating this forum, creating this place for shared experiences, probably a small conference, symposium series where developers talk about their work, getting some training materials up there, showcasing some of the successful work that we've done with the more in-depth collaboration, that sort of thing. What we'd also like to look at, which I think would be really interesting, is looking at activities across, in our space, across federal agencies. There's actually gateway development going on in the NIH, the National Institute of Health, certainly. Someone shared a set of slides from our Department of Defense where science gateways and web interfaces were mentioned, and so that really surprised me. Actually, that would probably be the last agency I would expect to see using science gateways, but it's really spreading across the agencies, and I think we're very siloed in that way and kind of not, we're doing a better job at sharing across directorates in the NSF, but certainly not across agencies. International boundaries, Sandra has helped tremendously with that, leading the international workshop on science gateways, and there's been a lot of great kind of cross-communication between those groups. That's kind of largely a European group up until this point, but I think there's a lot more that we can do in that space. We're not, so I mentioned that the institutes are not supposed to be about software development. We're looking at kind of some small modularized developments. So API-based snippets that people can use and incorporate into their own gateway frameworks. So maybe you want to capture a stream of censored data and analyze it. Maybe you want to be able to seamlessly run jobs on supercomputers? What are ways that other people have done that it's easy to just plop into your own project and use? So those are some things that we'll be looking to put forth. One thing that we're going to have to keep very much in mind is that this still is not about one specific approach to building science gateways. There are many, many approaches. There are many different packages that people use. We're not going to change that in this institute, and we don't want to change that in this institute. I mean, I think in the web space, we really have to get used to living with diversity and not sort of try to force single approaches, because really there will never be one. I think there's plenty of space for everyone to play in this regard, and an institute has to absolutely recognize that. So this is a little bit about what the modules look like. So probably Docker containers with fully populated, gateway in a box sort of software, but also these APIs. So authorization, event notifications, messaging systems, kind of account creation and control, and then of course the interfaces to the different hardware, so storage systems and clouds and supercomputers. And these are the sorts of things we'll be fleshing out a little bit more early on. Workforce development, this is pretty exciting for me actually, because I think web development, it's sort of such a natural area for students to play in. You see the results of your work immediately. It's really fun to program for the web. It's got the young people are using this every day, of course. I think it's much more compelling than writing an MPI program that's going to run on 10,000 processors, for example, and not that that's a bad thing. But I think we have a lot of opportunity to pull interested students into the science space through this focus on gateways. And I think it does a number of things for the students as well. If you're developing an effective science gateway, you've got to be able to communicate with the science teams and then translate that into an implementation that meets their needs. And that's a very unique and sometimes difficult to attain skill, but something that I think can serve them well in many sorts of things that they do as students. We lose a lot of folks I know at the San Diego Supercomputer Center to places like Google and Facebook and Twitter, and we'd really like to be able to keep some of these best and brightest in the sciences, and so I think this is perhaps one way to do that. I mean, I think another component of workforce development, this first bullet point here, is we see, and Sandra will say a lot more about this, but there are several universities in the U.S. that are really leading as far as developing kind of a core set of gateway expertise. Because if you think about it, here anyway, most gateway development is done on campuses by academic groups, and so a group will get a grant, and there's a science gateway associated with this work, and oh my gosh, we've got to hire someone, and we've got to hire this team of people and all the right people, and we all know how long hiring especially good people can take. Whereas if you have a group that has the right expertise on campus that all your PIs can take advantage of in this sort of time-sharing situation, that allows you to be much more effective when you receive grants in this regard. And also it develops, I think, kind of more sustainable career paths for people who are gateway developers. Notre Dame has done an absolutely tremendous job of building such a group, and I think Sandra's going to talk a little bit about that. But I can really see that as a, not just involving students in the work, but also kind of developing a place for them to go afterwards. Marcus, I don't have, oh, I think I'm about done. I was going to say I don't have a clock in front of me, so I'm not sure if I'm over or under time here, but this is actually the last slide. So this workshop series, both in the U.S. and now expanding, has been really a great opportunity to share experiences. We've done the U.S. series in a number of different venues, most commonly supercomputing, although it's not terribly well suited to that in association with some other conferences. But wherever it's been really, really popular. People have really valued the opportunity to interact. We often feature kind of poster components where people are really interacting, really getting a chance to talk to different developers. This got such good reviews when we did this last year at SC. SC would only grant us half a day for the workshop. Everyone who was there said, we need 3 times more. This was really rewarding. This was really a great idea. So we've seen a lot of success with this. We hope you will also see a lot of success. I'm very much looking forward to the event in October, and I only wish that I could be there in person. So we look forward to working together, and with that, I'll stop for any questions.
Thank you, Nancy. I don't see any questions in the chat at the moment. I'll let Sandra prepare to become the presenter.
Share my screen.
Okay. As mentioned before, if you have questions, just let us know in the chat or use the WebEx raise your hand symbol. And apologies for some of the audio issues we had earlier during the session, but it seems to have settled down now. And yes, Sandra, you sound good.
Oh, fantastic. Yeah, I only have to sit like this, I think. So yeah, my name is Sandra Gesing. I'm from the Center for Research Computing and from the Department of Computer Science and Engineering at the University of Notre. I moved to the US almost exactly 2 years ago. So I worked before that at the University of Edinburgh on data-intensive computing, and before that at the University of Tübingen in Germany on science gateways for bioinformatic applications. So I started with science gateways in 2006. That's also already 9 years. As Nancy, I don't feel like that it's already this long time. So many thanks also from me to Michelle, Loretta, and Marcus for organizing this webinar. And I will focus on the development of science gateways and the challenges for developers, what they face, and introduce some of the European projects I'm still also partly involved in. So the state of the art is that there's this data and compute intensive problems, like the SKA, the Square Kilometer Array Telescope. It will create extra scale of data. And the researchers, of course, want to analyze it. And there's also a new era, as we already mentioned that, with all the web-based Agile frameworks which are nowadays available. And there's a real push in that area. And we have the distributed data and computing infrastructures available to do our analysis. So like on national, on international scale, but also on campus level and local access. And there's, so Science Gateway developers have to deal with grid and cloud computing and distributed data management. And like AeRO, Cache, Lustre, to name a few examples. And they rely on high-speed networks also, because that is something you need, of course, if you have web-based applications. You need the high-speed networks to have really performant and efficient access. And on the other side, if you look at the left-hand side, there are also the tools and workflow engines available, like established open source tools or command line tools, and a lot of workflow engines like Galaxy, GUse 9, Pegasus. And not in computer science, but normally users, not generally IT specialists, So this is the situation a Science Gateway developers have to face, and the main goal is to make really the users happy. Science gateways are community driven, so you have to focus on happy users and that they get what they really need to focus on their research on. And so he has to deal with a lot of different topics, from parallel computing to data mining to get the results, to different workflow engines, different tools, and the different distributed systems. And often distributed data also, because it's, the one hand side is in the labs and the computing infrastructure are somewhere else. So one answer for this is, and Nancy already mentioned that also briefly, the frameworks and APIs which are available. So the key about that, it's reusability, because you want to be as productive as possible to create your Science Gateway and not reinvent the wheel. So the key to productivity is reusability. I really like that John Bourne said that already in '92, because he's right. The easiest way to produce code is obviously to have it already. Nothing is faster. And reinventing is not always necessary, but of course the solution has to fit the demands of the community. And there are a lot of different developments at the moment and technologies already. As I mentioned, the Agile web frameworks, some examples are AngularJS or the semantic UI. There are content management systems like Drupal. Content management systems are really made for publishing content, not really for big data. And so what they often lack for Science Gateway is it's a data collection of huge data amounts, that they can deal with that. So they're really good for specific Science Gateways. For example, if you have samples where you want to publish only small HTML pieces or small documents, for that they are fantastic. Or the libraries for implementation you can find, like Django in the Python world. They are fantastic for a connection to a database. But for example, directly access via these libraries to distributed computing infrastructure are not standardized. So developers have to start from scratch again if they want to connect to something else than local resources. But if you use local resources and maybe a standard database, then Django is a fantastic choice. So additionally, Science Gateway frameworks have been developed, like Galaxy. Some of you might know Galaxy because it's very famous, at least in the US and in Europe. WSP Great is also a workflow-enabled Science Gateway. You can install Galaxy and WSP Great out of the box, and you have your workflow engine included, and you have a graphical, intuitive user interface to use them to put together your workflows. The Catania Science Gateway frameworks and AeRO are examples which are more focused on collaboration. They can also submit jobs, but it's very focused on the community-driven approach of sharing with each other documents and results. And these Science Gateway frameworks, what they have all together, so they already have really submitters and connections and connectors to distributed data management or to distributed computing infrastructure. So the developer doesn't have to develop them from scratch. They have also some differences, how they were created, which language. Galaxy, for example, is written in Python, WSP Great in Java. Catania, the Catania Science Gateway framework is also Java. And some of them have a static layout. That might be for a use case fantastic because the user community is happy with it. Other ones, the layout extendable and maybe a totally different look and feel. And as I mentioned, Galaxy and WSP Grade have already a workflow engine integrated, while the Catania Science Gateway Framework and TAF0 are able of doing workflows, but it's an additional module, and it's not with a workflow editor. So there are these differences, and for each project, it might be a different framework suitable. And there's also APIs for implementation to make it easier to create really your own science gateways. So Apache Vata, Agave, and the Vine toolkits are libraries you can download. They're all open source, and they have already prepared libraries in the API to do the distributed computing connections, so that you don't have to care about these things, but that you can concentrate really on the look and feel of a science gateway, and you don't have to reinvent all the connectors to different infrastructure. So this is only, again, an overview on some of the science gateways. So a developer faces, even if he's aware of that there's all these APIs and frameworks and libraries out there, so it's again a bunch of them, as Nancy also already said. So this is only a small selection of mature science gateway frameworks you can find, or use cases you can find on the internet. And you can see here Galaxy, for example, on the left-hand side, or a project Cyget is a gateway platform as a service, offers the Apache Vata for different projects and to help with creating science gateways and even providing the resources behind. Or on the left-hand side in the lower corner, there's the Vine toolkit. They have this work from Poznan, and they have created really wonderful libraries also for visualization. So this is a widely used tool also in Europe. So the development of science gateways, we talked about it. What are the crucial topics really? If you look, let's say, from a higher perspective on Earth, and yeah, so two are the most crucial topics for them. It's for developers. That's the close collaboration with user communities and the knowledge about available technical solutions. And that sounds easy in the first view. But the requirements of a user community are often not so clear because they are not aware of what they can do, maybe, or what kind of technical solutions they can be offered. And some of the technologies you can find are still under development. The science gateway frameworks are already mature, but you may need, as a developer, a little bit additional features or additional functionalities. And then these are maybe still under development, and that means that you still have to have a larger effort for creating science gateway and maybe a slower uptake of solutions. So we discussed what is really, if a developer is sitting there and he has the duty to do a new science gateway, And so there are three main aspects you have to consider. One are the technical aspects. So that cannot be answered, or maybe some domain expert can answer that, but the technical aspect is the part where he decides what kind of language he wants, programming language he wants to use, what kind of infrastructure is available. The domain-specific aspects are, of course, the research that is behind. That is the main thing we want to improve, of course. We want to improve the experience of the domain experts, that they have really a benefit from the Science Gateway. And of course, there are organizational aspects. And we have developed categories and a kind of checklist. What do you have to have a look at? The domain-specific aspect is, first of all, the overall goal, what the Science Gateway should really deliver. So Nancy mentioned already, for example, in the humanities, maybe distributed computing infrastructures are seldom used. And you don't need them to connect to them, but you need to connect to data libraries or repositories, because they want a data collection. You have to have a look at the target area and the target users. So there's a big difference. I work most of the time with biologists and chemists, but also with physicists. And physicists, for example, like to do their own code. They like to do their own Python code and still have the command line. What they like is also to have a Science Gateway which is doing all the security stuff for them. But then they want to submit their own code, and the biologists I work with mostly like to have a graphical user interface. They don't want to care about what kind of program is behind it, as long as the computational method is the one they need. So some of the users also have visions or demands on the layout. As I mentioned already, some need maybe a graphical user interface for creating workflows. Some other ones only want the possibility to put in their own command line tools and submit them. So they will have some priorities of features and options. A project always gets tight. And of course, at the beginning, you want to listen to all the features and options they want to have in a Science Gateway, but they should, of course, prioritize that. And it's also very important to know whether there are existing applications or you need to develop maybe additional features to applications, or if all the methods are already in the way the users use them. And it's also different for web applications. Yeah, the technologies. So it's a big difference, even so with IPython nowadays, you can do a lot of things, but to integrate MATLAB or R in a Science Gateway is a different job than to integrate a Python program. One of the major challenges also still for the different data, which is coming up more and more, is the visualization of data. So we have worked together with a team working on mass spectrometry, for example, and they wanted to have this 3D nice visualization they can directly integrate in publications. So that is a totally different challenge to program that also in a web interface in a way that they can download it nicely to integrate it directly. Of course, there are security demands. For example, in drug design is a really expensive area, and the jobs are long running and the results, and they don't want to share their results before it's not really published or patented. So the security demands are really high in this field. And there's a difference between using single tools or having a whole workflow of different tools where the output of the one tool can be connected directly to the input of the next tool. The organizational aspect is more like, project management. So you have to consider the time constraint for the development and what is normally in a project given is something like deliverables, but maybe they are a little bit loose, like, okay, you have to deliver like after 8 months or something. Something that breaks it more down to milestones is very helpful. And an agreement on alpha or beta tester. I've seen a couple of projects where at the beginning everybody thought that they understand what the user community wants, and the user community thought that that they really didn't know what they wanted. And after half a year, it didn't look like the product directly like they wanted it. And they made more experiences, so it's really good to have always alpha and beta tester, and of course the regular meetings. I know that sounds all like normal project management, but sometimes in academia it lacks this organizational aspect. And the technical aspect from a developer side is really, of course, for the developers is also important whether they have already experienced with existing frameworks or programming languages. Not that they are normally stuck to one technology, but it could be that if they evaluate that there could be 3 APIs or libraries fitting, of course, the experience, if they have already experience with one, they can choose that. Or the available infrastructures, I mentioned them already. It only has to have a science gateway when there really also the infrastructures behind the people can use, and they have accounts to and get accounts to. Also, the support of suitable technologies is a very important topic. So even if there's something mature which would fit fantastically, if it's not supported after a while, or there's not a big community, open source community behind it, then it might be also the end of the project after the funding is over. And the scalability of suitable technologies. So some technologies, I mentioned that already, are really made for small amounts of data or for local resources. And that might be the right way for some science gateways, but it has to be clear whether the community needs maybe more or gets more users and or has at least the potential. And developers also need to have a look at the effort, what they need for extending existing technologies compared to some novel developments. So it might be less effort for a certain science gateway to take not only, but an API or a library instead of a complete science gateway framework, because for this specific case, it's easier to make some novel development than really extend a complex science gateway framework. And of course, at a university or existing projects where the developers involved in, it's fantastic to use some synergy effects between different science gateway projects. So there are some knowledge hubs. So the Science Gateway Institute was already mentioned by Nancy, but I will talk a little bit about centralized teams at university and also projects in general, where it's not only one university involved, but teams like an EU project with different technologies they're already using in the area of Science Gateway. And there's the IEEE technical area. That is really only a knowledge hub. There's some information. It's only a website. There you can find some information on publications, the workshops. The examples you see here on this slide are examples we have developed at the Center for Research Computing at Notre. So it's really from various varieties of democracy, to biology portals, to health portals. ICT Biomed is the worldwide consortium. Vector-based is the US consortium, and VecNet is also a worldwide consortium, and the Science Gateway is hosted at Notre Dame. And the CSC, the idea with the CSC was at the beginning that it's a HPC center, how you can find it at many universities. And more features and services were added to the profile, like software profiling. So there's, on the one hand, really the Science Gateway development, but we have also experts for geographical information systems and visualization support, which can be done, again, also integrated in Science Gateway. Computational scientist support, so I'm also a computational scientist for the Center for Research Computing. They really help with collaborative research and grant development. And a starting point was always a system administration, design, and activation of HPC Center. At the moment, we are about 40 researchers, research programmers, and HPC specialists. And research programmers are the ones who are really developing the Science Gateway. And the researchers, like the computational scientists, are helping with the design and grant development. And one of the projects, the ICT Biomed, that was set up, for example, with the CSC at Notre Dame, together with teams in Chalmers, in Poznan, and in CEDAC in India. So Poznan in Poland and Chalmers in Sweden. And it was first, so it was clear that we have the resources and we have the knowledge to offer really a cloud to the users and connecting them together worldwide. The internet connection is there. Of course, we have also sometimes bandwidth problems between the continents. But what we are doing at the moment in this case is writing together with researchers worldwide grants to really offer them the use cases as Science Gateways to support the collaboration between the different continents. And where the researchers, for example, come from quantitative imaging, and they work together with different researchers all over the world. Another action we are involved in is a EU cost action, ChipSet, high performance modeling and simulation for big data applications. Since it's a EU action, we are non-cost partners. That means we don't get money. I like the idea about the cost action. And as you can see, also from Australia, we have partners involved in that action. And we cannot get money in the first step except for traveling and meeting for workshops. But the goal of these actions is really to write together grants and to set up an infrastructure and to get the funding to work together. And in this cost action, for example, we are concentrating on 4 different working groups. That is the big data infrastructure, parallel programming models, which is very on the computer science side of the project, but we have also user communities involved in the life sciences, for modeling and simulation for life sciences, and socio-economic and physical science. And we plan to work together in this project to develop technology and for big data between HPC and big data and have integrated frameworks reusing existing technologies. And other cost actions already declared their interest for collaboration, like NESO's Network for Sustainable Ultra-Scale Computing. Keystone is focusing on semantic keyword-based search on structured data sources, and APLI algorithms, architectures, and platforms for enhanced living environment. I won't go into detail for each of these projects, but it's only maybe a thought that it could be also interesting for you to join some of the projects, because these cost actions are open for any partner who wants to join and who's interested in working on that topic. And it provides the possibility to write grants together and get funding to really be able to do some work together. As always, of course, we need money to finish some project. DGI Engage, it's so maybe most of
sorry to interrupt, Sandra. I'm just trying to see if Carl Nissen, can you maybe try and mute your audio, please? I can't turn it off from the software.
Mine's saying muted.
No, I can hear you. You've got more than one microphone. Thanks. Sorry, Sandra, to interrupt. And just draw your attention to the time. We're running a bit out of time.
Yeah, I will be faster now, and it's not so much anymore. So yeah, so EGI, you might have heard about EGI. It was European grid infrastructure. They got new funding for the next 5 years, and it's now enabling global infrastructure. So that might be also an interesting project. Australia universities can connect to, and it's also offering services and knowledge training for science gateways. And it has already one partner also in Australia, as you can see on the map. And I'll make it now a little bit faster. So the Indigi Data Cloud is also a fantastic project around science gateways. It has 26 partners from 11 countries in Europe, and it will offer all the services as open source. And what I was excited about is, if you look at this graphic, all the yellow parts, they're using existing technologies. Well, they're not developing it from scratch. Only the orange parts will be new developed, and not only the orange parts will be new developed, but it's really reusing existing technology and not developing it from scratch again. The Cloud SME project is a project, I like the goal about it, that it brings in the industry, that it brings in SMEs. It has 16 partners, and more half of them are SMEs. And if you're interested in working with them on really providing an extraordinary cloud infrastructure and science gateway, you can join the project and get their results. And they're developing with a different cloud, underlying cloud, in the industrial and commercial and academic clouds, which is very exciting, I think. So that's my last slide. So I hope I stayed almost in time. So yeah, the Science Gateway workshops, Nancy already introduced them. It's on the 19th of October in Brisbane. It would be very exciting to seeing you there. And if you want more information on Science Gateways, there's a Science Gateway Institute, the technical area on Science Gateway. Nancy mentioned the XSEDE Science Gateways. You can have an overview there. Or the CRC Science Gateways I mentioned, if you can have a look there. And this is the program of the workshop. So it will be a day with Nancy as keynote speaker, different talk about really exciting different topics in the Science Gateways, and it will furnished the day with a nice panel discussion on the future of science gateways. So thank you for your attention, and if you have any questions, I'm happy to hear them.
Thank you to Sandra and Nancy. And apologies for that earlier breakdown in the audio during Nancy's presentation. Not sure what happened there. The recording will hopefully turn out better than that. Any quick questions for Sandra or Nancy? Either via chat or feel free to unmute, stick your hand up. All right. We'll put the email addresses for Sandra and Nancy up as well, so you can get in touch with them. And we'll put the webinar recording as well as hopefully the slides from both speakers up on the AeRO website. I would encourage people, if they have interest in other related e-researchy kind of webinars, to please let me know. We're trying to set up a range of more webinars and events like this. There's a question coming through, I think, on chat. Rashna, I can just unmute you. More information on the Australian Web Seminar is on the eResearch Conference website. So we'll put the link to that particular part of the program on the AeRO page as well. And we'll put a tweet out for it as well. Any other questions? All right, thank you very much. I'll pass on a virtual round of applause to our two speakers. Thank you all for coming along today. As mentioned, we'll get the seminar, the webinar recording up as soon as we possibly can. And I would like to thank the Cordit folks for providing us with WebEx today. Interesting little feature that I can mute almost everybody, but not some people. Anyway, thank you very much all. Have a wonderful afternoon, and hope to see you again one day soon, and at the very latest at the workshop in October.
Very much, Marcus.
Thank you. Yeah, looking forward to seeing you in Australia.